So if the masses of ball bearings produced by a manufacturer must be tightly controlled so that the mass varies by no more than 0.5%. Okay. And that's realistic. That's like if you're buying, you got to use ball bearings and everything, right? I mean, so you're using ball bearings and all these mechanical things. There need to be pretty tight tolerances on that. And so one way we could do that is by measuring the mass. What's the mass going to be a proxy for here? Volume, right? Because the density of the steel in the ball bearing is uniform, and so mass is going to be proportional to volume in this case, right? If the density is uniform. So we would measure, it's harder to calculate volume. It's really easy to calculate mass. So we would essentially the mass would be a proxy for the volume here, right? So we're tightly controlling the volume of these spherical ball bearings. So what's the allowed variation in the radius of the ball bearings produced by the manufacturer if we want the volume to vary by no more than plus or minus 0.5%? Wait, how are we going to approach that one? Okay, so dV is plus or minus, right? The relative propagated air in this case, because volume is going to be the calculated quantity, right? Radius is going to be the input quantity, right? Everybody agree with that? Okay. So we know that the relative propagated air cannot exceed 0.5%. This is a different kind of question. Now they're wanting us to know how tight a tolerance do we need in controlling the radius of the ball bearings. Yep. Well, exactly. Yeah, that's what we're going to do, right? So we know we've got, we can skip through that. We already talked about that. Okay, so we know that dV over V is going to, and you can look at this in the notes if you want to. It's just comparing mass to volume. We'll come back to that if we have time, but I want to make sure we get through the calculus part of this. So essentially what this is telling us is that dV over V has to be less than or equal to plus or minus 0.005. 0.5% as a decimal would be 0.005, right? Okay. We know that this is, so what is the volume? Well, it's a sphere, right? We're talking about spherical ball bearings, so volume is just the volume of a sphere, 4/3 pi r cubed, and we could differentiate that pretty easily and get dV equals, dV dr is 4 pi r squared, so the differential dV is 4 pi r squared, the derivative, times dr, right? Okay, so now we could use that to build a function for relative propagated air, right? That's just going to be dV over V, right? Okay, dV is the propagated air. The relative propagated air is just dV over V. And so we can do this math pretty easily, right? 4 pi r squared dr over 4/3 pi r cubed. 4 over 4/3 is 3. We can cancel an r squared top and bottom, and we get 3 times dr over r. Well, there's our dr over r is the measurement air, right? That's what we're trying to find, is what should dr over r be. So I could just divide each side through by 3 then and solve for the quantity dr over r. That's pretty cool that we can do that. So dr over r has to be less than or equal to, plus or minus, could be in either direction, 0.005 over 3, whatever that is. And if we make it a decimal, it's that. Right? If we write it as a percentage, we just slide it over 2 places. And so we have to control the radius of the ball bearings. It has to be, the tolerance is pretty tight. The ball bearings the radius can't vary by more than 0.167%. Okay. What if we needed to know what the absolute measurement was? Well, then we just would have solved for dr, right? We could have solved for dr in this thing. We have this, like, what if the question was, well, what is the number? How much can the ball bearings, and I guess we need to know, what would we start with here? I don't think I gave you the target volume, right? But if we wanted to know how much can the radius vary, we could use this relationship right here. And if I solve that for dr, I get dr equals dv divided by 4 pi r squared, right? So I would need, what would I need to know here? Well, I would need to know what the radius was of the ball bearings that we're building, right? Does that make sense? And I would need to know what dv is, right? Well, dv is just 4 pi r squared dr. So I could replace that with 4 pi r squared dr, and all those cancel. Oh, whoops, that's not going to work. I just got dr equals dr. What do you know? Can't do that. We would have to have some information. We would have needed to know some more specific information, like what are the ball bearings that we're producing here, right? Like what's the target radius that I could plug in to calculate what the actual value of R is, right? But that's not what was asked. We just needed to know, all they wanted to know was, what was the question? I guess they never said I never stated the question explicitly, but we want to know, oh, there it is. What's the allowable variation in the radius? The allowable variation as a percentage is plus or minus 0.167%. Okay? Does that make sense? Give me thumbs on that. How are we doing? Okay. Now we're getting to a point where you got to do it a little bit, right? I'm kind of filled the cup up with information, and are we about out of time anyway? 2 minutes. Okay, I think I've got a couple more. We'll look at maybe just 2 more quick examples next time, and then I'll give you a chance to. Those should go pretty quickly, and then you get a chance to work and ask some questions.